Welcome to Insights into the Industrial Revolution, Part 8, Lighting the Way. One of the chief problems facing the growth of industrial activity in the late 18th century and early 19th century was that of lighting. Up to that time, homes and business premises had been lit by candle, by tallow light, or by similar methods, mostly using animal oil. Those methods are smoky, smell unpleasant, and don't give a very good light. They weren't very suitable for larger premises as entrepreneurs began to develop factory production. In addition, the first industry to develop factories was the textile industry. The dust from these textiles hung in the air, and cotton fibres in particular are extremely flammable. Candlelight simply wasn't going to work. New solutions were needed. Whale oil. In the early part of the Industrial Revolution, whale oil provided the solution to lighting the factories that were springing up. I covered the whaling industry in Part 7 of Insights into the Industrial Revolution. Whale oil burned cleanly and brightly and without much odour. Placed in lamps above the miasma of the cotton dust, factories could be lighted cost-effectively, and production could continue beyond daylight hours. Whale oil was the principal form of lighting in factories and cities until the late 1820s, when it was overtaken by gas lighting. Lighting with gas. The clergyman scientist Stephen Hales discovered that heating coal produced a flammable gas in 1726. Little notice was taken of his discovery for around 60 years. Some scientists conducted experiments with coal gas, but its application for lighting was not realised. In 1784, Jean-Pierre Minkelaers, a Dutch academic, had a lecture room in the University of Leuven, in Belgium, lit by gas distilled from crude oil. He also studied gas formed by heating coal. However, the Belgian Revolution of 1789 forced him to flee from Brussels, where he was working at the time, and he does not seem to have returned to his studies in gas lighting afterwards. However, he is credited with the invention of gas lighting. Archibald Cochrane, Earl of Dundonald, patented a method for making coal tar in 1781. One of the byproducts of coal tar production was coal gas, and he used that coal gas to light his house and other properties on his estate in 1789. However, the concept was not exploited commercially at that time. As a side note, the British Tar Company was formed to produce coal tar using Archibald Cochrane's method. Their factory was managed by John Loudon Macadam, who, in the early 1800s, invented the macadamisation process for road building, for which his name is known. William Murdoch was a member of the senior management of Boulton & Watt, the manufacturer of James Watt steam engines. He was an extremely inquisitive inventor, and one of his areas of interest was gas lighting. He is credited with commercialising the technology. In 1792, Murdoch began experimenting with the use of gas for lighting. By 1794, he was producing gas by heating coal, and in 1797 he installed gas lighting in his home in Cornwall. William Murdoch returned to Birmingham in 1798 to manage Boulton & Watt's main factory. He began to install gas lighting in the factory, and in 1805 installed gas lighting in a cotton mill in Manchester. This was the first commercial premises in the world to be lit by gas, and it contained over 900 gas lights. The Boulton & Watt Company continued to install gas lighting in mills and factories in the early 1800s, but the company's focus was always on steam engines, and they abandoned the gas lighting business in 1814 as other companies rose to prominence. Samuel Clegg had been an apprentice in Boulton & Watt and later became an assistant to William Murdoch. He realised the potential of gas for lighting and left Boulton & Watt to work on his own account, installing gas lighting in mills and factories in Yorkshire and Lancashire. Coal gas is formed by heating coal to form coke. Coal tar and coal gas are also formed during this process. Coal gas is a mixture of hydrogen and methane with other gases, including carbon monoxide and sulfur. When coal gas was burned, it smelled of rotten eggs, and the sulphur would react to form sulphuric acid, which is not pleasant to have in your home or business. The coal gas therefore has to be purified before it can be used commercially, and Samuel Clegg invented a more efficient method for purifying coal gas, using lime. The Gas, Light and Coke Company was established in London in 1812 and was the first company to produce coal gas on a commercial scale. Laying wooden pipes, it illuminated Westminster Bridge in 1813. In 1814, Samuel Clegg became chief engineer for the company, and in 1818 he patented the first viable gas meter, allowing the usage of gas to be charged to its customers. In 1819, the Gas, Light and Coke Company had installed nearly 300 miles of gas piping in London. Over the next 150 years, the company expanded across the southeast of England, and by 1948 it served a population of 4.5 million people, with 13 gasworks and 21,000 employees. The company had a large transport fleet, including ships, barges, railway wagons and locomotives, to bring coal into the gasworks and to take coke and other products out. In 1949, the British government nationalised the company and it became British Gas. But let's return to gas lighting. The first street in the world to be lit by gas was in 1806 in Salford, near Manchester. In the same year, a street in Rhode Island was also lit by gas. The first town outside of London to have gas lighting was Preston in Lancashire, with the formation of the Preston Gaslight Company in 1816. The main streets and houses on them in Bristol switched to gas lighting in 1817. Baltimore was the first American town with street gas lighting, also in 1817. In 1817, the Gas, Light and Coke Company in London had 3 gasworks, producing 8,500 cubic metres of gas per day. By 1823, gas lighting had spread into many towns and cities in Britain, and gas cost about 75% less than candles or whale oil. By 1859, every major town in Britain was lit by gas, and there were around 1,000 gasworks. The production of coal gas was an unhealthy business for the workers in the gasworks. In the 1830s, the survival rate for those feeding the furnaces was around 8 years before they were struck down with pulmonary consumption, which we now call tuberculosis. The technology continued to develop. In 1891, the gas mantle was invented. This gives out a much brighter light than a gas flame, allowing a cheaper, less refined form of coal gas to be used. Coal gas continued to be used in Britain for gas lighting until the early 1970s, when it was replaced by natural gas from North Sea oil drilling. The Industrial Revolution was largely lit by gas, but kerosene and electricity also played a part, as we shall see. Kerosene lighting. Whale oil had been used to light factories and other premises during the early part of the Industrial Revolution, until coal gas took over from the 1820s. However, outside of the main towns or industrial centres, whale oil continued to be used. Kerosene was first made from coal by Canadian geologist Abraham Gesner in 1846. It made an excellent lamp oil, but was expensive to produce. He didn't obtain a patent for his process until 1854, when he also registered the word kerosene as a trademark. The North American Gaslight Company began to manufacture kerosene from oil shale in New York State around this time, later expanding to Boston. In 1848, James Young, a Scottish chemist, experimented with shale oil and produced what he called paraffine oil from it. Kerosene and what we now call paraffin are the same thing. James Young patented his process and began to produce paraffin from shale oil extracted on the outskirts of Edinburgh in 1851. Approaching Edinburgh from the west, you can still see the huge pink mounds of shale waste today. Samuel Martin Keir is credited with the founding of the American petroleum industry. In 1851, he began distilling a product he called carbon oil from crude oil. Again, this is the same product as kerosene, which was protected by a trademark. Drake Well in western Pennsylvania was opened in 1854 and was the first commercial oil well in the United States. The US oil industry took off from there, and the product, widely known as kerosene, was distilled from crude oil rather than from coal. Kerosene, or paraffin as we call it in the United Kingdom, began to replace whale oil for lighting in factories and other premises from the 1850s, and the whaling industry declined dramatically. However, kerosene was not without its risks. In 1880, nearly 2 out of every 5 New York City fires was caused by defective kerosene lamps. This was partly due to the adulteration of kerosene with cheaper, more volatile hydrocarbons. Electric lighting started displacing kerosene for lighting in the late 19th century, especially in urban areas. The production of kerosene by the oil industry decreased as the demand for gasoline for the newfangled motor car grew. Today, kerosene is mainly used for fuel for jet engines in several grades. One highly refined form of the fuel is known as RP1 and is burned with liquid oxygen as rocket fuel. Electricity for lighting. Did Thomas Edison invent the electric light bulb? The short answer is no, but he was very important in its development, and more importantly, he developed a complete lighting system which made electricity commercially viable as a means of lighting. We'll come back to Mr. Edison presently. Electricity itself has been known about for centuries, although little understood. Electric fish were used by the Romans in health care to give a shock to patients. The English words electric and electricity were first used in a book published in 1646. Isaac Newton made some studies in electricity, and Benjamin Franklin famously advanced the science in the 1750s. Alessandro Volta developed a form of electric battery in 1800, and other scientists developed the understanding of electricity. Michael Faraday invented the electric motor in 1821, and James Clerk Maxwell extended Faraday's work to show how electricity and magnetism were related in 1861. In 1865, he showed that light is also governed by electromagnetic laws. Albert Einstein built on James Clerk Maxwell's work to develop his special theory of relativity in 1905. The first example of electrical engineering was the development of the electric telegraph, which spread across the world from the 1840s. Anyway, now let us return to the problem of electric lighting. In 1838, Marcelin Jobard, a Belgian newspaper owner, created an incandescent light bulb using a carbon filament in a vacuum. But he didn't continue his researches in this area. In 1840, Warren de la Rue, an inventor and pioneer of astronomical photography, experimented with passing an electrical current through a platinum coil in a vacuum tube. Unfortunately, the high cost of platinum made this impractical for commercial use. Further incandescent bulbs were developed through the 1840s and 1850s, some using carbon filaments and some using platinum. Perhaps the most important was that created by the researcher in electricity Moses G. Farmer in 1859. He lit his house in Salem, Massachusetts with electric light, the first in the world. With his business partner William Wallace, Farmer invented an electric dynamo which he used to power his lighting exhibit at the 1876 Centennial Exhibition in Philadelphia. Thomas Edison saw this exhibit and was inspired to improve the incandescent light bulb. Thomas Edison was a born businessman, and his first patent in 1869 was for an electric vote recorder. He was 22 years old. With his mentor, Franklin Pope, Edison developed a form of telegraphic system which could send 4 separate signals through the same wire at the same time. He sold a system to Western Union for $10,000, which is around $300,000 at today's prices. And he used the money to build a laboratory at Menlo Park in New Jersey. In 1878, he began working on electric light, testing many different filaments and eventually deciding that bamboo filaments gave the longest life. Edison bought up the patents of other inventors who had created electric light bulbs, including that of Moses Farmer, to avoid competing claims, and he was granted a patent for his own light bulb in 1880. In 1878, the Edison Electric Light Company was formed and installed his light bulb in the steamer Columbia in 1880. However, the first electric lights in New York City were installed by Edison's rival, Hiram Maxim, in 1879. Maxim would go on to create the famous Maxim machine gun in the 1880s and 1890s. While working for Hiram Maxim, a young inventor named Louis Latimer patented an improved method for making the filaments for electric light bulbs in 1881. Latimer managed the installation of the Maxim lighting system in New York, Philadelphia, Montreal, and London. In 1885, Louis Latimer switched sides and went to work for Thomas Edison. But before we continue with Thomas Edison's contributions to electric light, we need to consider Joseph Swan. Joseph Swan was an English inventor born in 1828. In 1850, he began experimenting with electric light bulbs, but was foiled by the inability to create an effective vacuum inside the bulb. Consequently, in 1863, he invented a vacuum pump, which was improved by Hermann Sprengel in 1865. Sprengel's vacuum pump made the commercial manufacture of light bulbs viable. With a better vacuum at his command, Joseph Swan returned to the study of the electric light bulb in 1875. By 1879, he was demonstrating his bulbs in lecture theatres across Britain. In 1880, he was awarded a British patent for his light bulbs, and in 1881, he founded the Swan Electric Light Company. The first public building in the world to be entirely lit by electricity was the Savoy Theatre in London in 1881, and it was Joseph Swan's company that supplied the system. The Times newspaper described the electric lighting system as vastly superior to gaslight. So we see that both Thomas Edison and Joseph Swan patented electric light bulbs in 1880 in their respective countries. This meant that Edison could not sell his system in Great Britain, and Swan could not expand into the United States. The two men decided to collaborate and formed the Edison and Swan Electric Light Company in 1883. The company was popularly known as Eddy Swan. The glass bulbs the company produced were of Joseph Swan's design, while the filaments were Thomas Edison's. The company survived until 1928, when it was absorbed into the Associated Electrical Industries. Electric lighting spread rapidly across the world. In 1913, William D. Coolidge, working for General Electric, patented the tungsten filament for electric light bulbs, which greatly extended their life and gave out a brighter light. Coolidge also invented an improved X-ray tube in 1913, advancing the medical speciality of radiology. Neon lighting was invented in 1910. The development of the light bulb continued into the 20th century, with the introduction of argon instead of a vacuum in the bulb, patented in 1916, and the mass production of coiled filaments in 1936. In 1885, an estimated 300,000 light bulbs were sold with carbon filaments. In 1914, over 88 million light bulbs were sold, most with tungsten filaments. By 1945, around 800 million bulbs were sold each year. Nowadays, incandescent bulbs have been largely replaced by LEDs, which are much more energy efficient. And so electric light replaced gas light, which itself replaced whale oil as the most effective form of lighting the factories and buildings of the Industrial Revolution. Before we leave the lighting of the Industrial Revolution, let us briefly consider the lighting of mines, where gas and other flames were never suitable. Down the mine. Lighting had been a problem down mines for hundreds of years. The mining industry in the 18th century was very primitive. All the work was done by hand, and problems with water ingress and flammable and poisonous gases meant that pits could not extend very far or deep. There was also the problem of illumination, since the use of naked flames and the ever-present danger of flammable gases being released was a dangerous combination. Eye strain was a real problem for miners. Often candles were used for illumination, but mines produced toxic and flammable gases, and explosions were common. To try and deal with the methane and other flammable gases that seeped into mines, firemen were employed. Dressed in dampened leather or wool suits, these men carried a lighted taper on a long pole through the mine. The colour of the flame would change in the presence of gas, and the mine could be ventilated to allow the gases to escape. At other times the taper was used to ignite the gases. It can't have been a very safe job. Another way of providing some illumination, introduced in the 1730s, was to spin a metal disc against a flint. The sparks emitted provided some illumination, and supposedly had a lower risk of igniting the flammable gases. However, some explosions were caused by this method. Sir Humphry Davy, the famous chemist and inventor, developed a safety lamp in 1815, which used wire gauze to contain a flame. Unfortunately, the gauze quickly rusted in the damp conditions of a mine, and the lamp became unsafe. George Stephenson, before he became a famous railway engineer, also developed a safety lamp in 1815. He used different principles to Humphry Davy's, but his lamp was also prone to damage. Better safety lamps followed. Lighting with a naked flame was never safe in the mine, and coal gas and kerosene, which lit the factories of the Industrial Revolution, were therefore unsuitable. The problem of lighting mines remained until the early 1900s with the introduction of electric lighting and battery torches. Thank you for watching this insight into the Industrial Revolution on lighting the growth of industrial activity in the 18th and 19th centuries. Goodbye.